For this example, we will rewrite the quantity as an algebraic expression of x and state the domain on which the equivalence is valid. What we are going to rewrite is cosine of arcsine of x over 2. Now, in order to come up with an expression of x, in order to get this so we don't have any more trig functions, an algebraic expression, what I'm going to do is consider arcsine of x over 2 as some unknown angle measure a. Meaning that I'm really just trying to work with cosine of that angle measure a. I don't know too much about a, but that ratio of x over 2 I could say is arbitrarily positive. So I will just write this in quadrant 1 to represent our angle measure a for a right triangle. We are told arcsine of x over 2, which means that a is an angle measure such that sine of that angle measure is equal to x over 2. Since we know sine is supposed to be opposite over hypotenuse, and that means we can represent in this triangle the opposite side as x and the hypotenuse side as 2. If I can determine the adjacent side of this triangle, then I should be able to figure out cosine of a, which should be a fraction of adjacent over hypotenuse. And since I already know hypotenuse is 2. Well, to find that adjacent side, all that takes is the Pythagorean theorem. Pythagorean theorem there for the adjacent side would be the hypotenuse side squared, so 2 squared, minus the opposite side squared, x squared. Or 4 minus x squared. That means I now should be able to write this value of cosine of a as the ratio of the adjacent side square root of 4 minus x squared divided by 2. That's part of my answer. We have now rewritten this as an algebraic expression of x. The only thing left is to find the domain on which the equivalence is valid. To do that, there's a couple ways to go about this. You can either go the algebraic way or you can go the trigonometric way. If you go the algebraic way, consider that in this expression, the only thing I'm really concerned about is that the value underneath that square root is 0 or greater. If it's negative, then I'm not going to get a real answer. So I need to make sure that expression underneath the square root is 0 or greater. So 4 minus x squared bigger than or equal to 0. If I subtract 4, I'll get negative x squared is greater than or equal to negative 4. And either multiply or divide by negative 1, which means that x squared is now less than or equal to positive 4. Multiplying both sides by the negative will flip that inequality. When you take the square root of this, though, that's actually going to split this function up, or this inequality up. If I take the square root of both sides, what this really is going to result in is that x has to be less than or equal to the square root of 4, which is 2, but also that x has to be greater than or equal to negative 2. So I now have a domain for this. That's one way that we can evaluate this question. The other way that we can evaluate this is to keep in mind that the original question was involving arcsine of x over 2. When you plug values in for arcsine, the only thing you need to be concerned about, really, is that the value that you plug into arcsine is between negative 1 and 1. So, negative 1 is less than or equal to x over 2 is less than or equal to 1. I'm getting this from the domain restrictions for arcsine. If I then multiply all sides of this inequality by 2, I will get negative 2 less than or equal to x less than or equal to 2. So I get the same answer. I would highly recommend when going through these problems to maybe consider the trigonometric way for going about this, so you can more familiarize yourself with these inverse trigonometric functions.